Okay. I need to zoom back. Okay, now do it. Okay. The simulator is completely on. All 4 computers are online. The sim is currently set up in the off configuration. So what we have is a dark, cold cockpit. I'm going to walk you through some of the sequences to start the power to the airplane. I'm going to reach up here on the overhead panel and turn on the battery switch, and when I do that you'll see some lights come on up here on the main instrument panel. Also on the overhead we had some lights come on that illuminate only from the battery circuit being activated. And up here the DC meters came online. I'll turn them off so you can see them go out. There's battery off, battery on, and down here on these lights, battery off, and battery on. You can also see that affects our HSI down here. There's battery off and battery on. Okay, so we have our battery on. That energizes our DC system. I'm going to look up here on our power indicator. We have ground power on, available. This will not illuminate, even though there can be ground power hooked to the aircraft, external power. If we don't have that, only energizes our bus system if the DC battery is engaged. So anytime I turn off the battery switch, we lose all of our connection to the external power. So we can see here we have our ground power light on. It's kicking off our transfer buses anytime those are engaged. If I go up here on this meter now, I can select ground power, and we have 400 hertz power on our meter and on the standbys. All this switch does is just shows us if a position has power on it. It doesn't actually select anything, it's just a monitoring feature. So if I turn off the battery switch, now you see, since I have the selector on ground power, it disengaged ground power to the aircraft. I'll turn on the battery switch, and there's our DC power came on, and our AC power coming from the external power cart. Okay, since we have external power, I can now select power to the aircraft, and it's going to get real bright in here because all the lights are on. There you go, there's our overhead. And down here, pretty dramatic. Oh, I'll pull back and turn off our AC power. It goes off. Everything comes on. Same for down here on the throttle quadrant. External power off, external power on. So I'll show you real quick on, we have a lot of floodlight options here. This is on our throttle quadrant. This is the overhead flood. You can see the light come up and go down. That's this guy up here. You see the light going up and down on the overhead. That's a very handy light. Turn that off. Up here we have our red light on a dimmer, and then this white dome light is just on a switch on the overhead. Then we have down here, some of these indicators are on the quadrant, throttle quadrant dimmer. All the 5 volt lighting is there. You can see that goes up and down, and it affects it up here as well. Bring it back up, take it down. This lighting here is not 5 volt. That's why it's not through a 5 volt dimmer. This is 26 volt AC. The lights are not parallel, they're in series, so they have the right amount of bulbs in series so that it draws at 26 volts down and ends up being 5 volts to each bulb when it's said and done. And that's the reason I can't run this lighting through the 5 volt dimmers. It's spreading 26 volts out across the bulbs to get 5 volts to each bulb. And it's a lousy system in these old panels, because if you lose one single bulb, it knocks out the whole panel. And I had to replace a lot of light bulbs in these panels to get these panels to work again. So we also have up here our lighting for the captain's panel, backlighting. This is our flood for the entire overhead here, and I can go to the fluorescent flood lighting, and then down to the dimmer lighting. This is our center stack lighting. That also controls the overhead, the glare shield lighting, as you can see there. So we have a flood for the first officer side, and then there's a controller over here on this, down here on the left side. This is our map light hooked to a dimmer. Oops. I gotta turn the switch on, then I can control the dimmer on the map light. And there's one on the other side as well. So we have quite a few floodlights. So anyhow, we're sitting here, we have our lights on. I'm going to turn on our radar screen down here. I'm going to come up to our overhead, and we will start our generator, our APU generator. So first of all, when we look at this panel here, I may need to turn some more lighting up for the camera. Okay. The two blue lights are showing our generators are out. This is generator number 1 for a left engine. This is our second generator, and engine number 2. These two switches control the APU generator, which is this light. So anytime a light is illuminated, the generator's offline. Except for the APU. The APU has an override position, so that light's not illuminated during the whole flight, since it's normally off. So when I come down here to the APU switch and I put it to, I'd place it from off to on, the light override turns off, and now we can see that the generator is disengaged. Now I can look up here on our overhead on our generator system, and we can see that If I put it on generator 1, we have no power. If I put it on APU, there's no power. Generator number 2, there's no power. So what that means is none of the engines are running, because we have a jet engine that spins up each generator. So if this was on, this would tell me, number 1, that jet engine is operational. Number 2, that the generator that's hooked to that jet engine is operational and putting out power. So I'm going to put this on APU. Now we will go ahead and start our APU. I'm going to push the APU switch into the start position for approximately 3 seconds, and nothing happened. The reason is I did not turn on the fuel system. The APU cannot run without fuel, so I have to engage fuel. This is our fuel panel. Now I'll try it again. There we go. Now that it's starting to come up, and you can see down here APU light briefly comes on whenever the APU is starting, and you can see up here we have 400 hertz power coming from the APU generator. Once again, now if I move this to generator number 1, no power because engine number 1 is off. APU engine is running and it's spinning that generator, so we have indicator now. Engine number 2, there's nothing. So now we have power running off the APU. However, because we have not engaged that generator into our electrical bus, we're not getting any power of it in our electrical system. We're still entirely operating off our AC power off the ground power card, the external power card. So now I'm going to engage the generator on the APU, and you can see our light went out. So what this means is we now have AC power from the APU generator powering our AC bus. At this point I can actually turn off external power, and you see our lights stay on because they are operating on the generator. However, at this point, because our main generators are offline, we have no external power. If I disengage the APU bus by placing this to off, you can see we lose all AC power. Now if I re-engage the generator from the APU, we get all our power again. Okay, so our APU is on. We would at this time go ahead and turn on all of our fuel pumps, go through our panels. Technically we're supposed to wait a minute before we engage our starters off APU power. And I'm going to engage our hydraulic pumps. Okay, so we now have fuel and hydraulics. Before we can use the APU, I have to engage the APU bleed air, which actually it was already in the on position. So it's on. Our bleed air from the engines is off. Now I have to come down here and engage the start arming valve. Okay. If those are off, the start switches will not function. So those both have to be on. Now I'm going to, we'll start engine number 1 first. I'm going to place this into start position. You can see that switch is holding itself. Come down here and we can see our engine is slowly spinning up to 20% RPM. There it is. Now I'm going to place this into start. Our engine came up. You heard that snap. That was the start switch up here turning itself off. The next one I'll let you see the start switch turn off. Okay, I'm going to place this into low ignition. Since this is a United jet, I'll move this lever from start position to idle. Now we'll start the process for number 2. And you'll see up here, this is the fuel valve closed light. It went out as the engine came up. Okay, put our engine into start. We'll watch that switch. There, it turned off. Okay, so now both of our engines are running. I'll put this in low ignition, turn off the start arming valve. I'll go ahead and engage all the bleed air, and then come over here to our generator power. Okay, I'm going to go ahead and show you one more thing. I'm going to kill one engine and you'll see the meter come online on engine number 2. So I'm going to put the fuel lever into off. It'll kill that engine. When the engine spins down, it'll stop driving the generator. Make sure that's engine number 2. Once the generator goes offline, there you go. We have no power because engine 2 just shut down. So I'll go through the process again. Start arming switch on. Engine start switch to the ground position. Now it's spinning up the engine. You see the generator's putting out power, so our meter came on. Let you watch this again. The engine to ignite, to start position. There, it kicked off. Now we'll go over here. I will engage the generator from engine number 2. It came on. Generator from engine number 1. It came on. Okay. Now we'll disengage external electrical power and we'll lose those indications. So now this switch does nothing if I turn it on. It's just dead. I will now turn off generator power on the APU. APU is still running, but it's not connected to the bus system. Okay, now if I turn off all 3 generators, because I have external power off, without all 3 generators, we lose all power out here and our master caution light comes on. There's our master caution light. Okay. I'll re-engage the generator to turn on our AC system. There you go, showing we have 2 generators off, 1 generator on. I turn that generator on, knowing I'm going to shut off the APU, and what'll happen is when I shut it off, that off position overrides the generator light, so the generator light is off during the flight. We don't have that interface. This is how this panel should look when we're in flight. Everything off. So if I go back up here, generator 2 has power, APU is off, generator has power, ground power is now off because ground power was disengaged from the aircraft, but we have standby power coming from the transformer rectifiers. That's AC power coming from the battery because we have our battery is engaged. Now if I in standby power, if I turn off the battery, we lose that. We no longer have power coming from the battery through the transformer rectifiers. But if I put the AC power switch to monitor generator number 1, we can see we do have AC power coming from generator number 1, and we have AC power coming from generator number 2. So when I turn off the DC power, we do lose a few things in flight, but you can see we have all our main lights and everything because they're running on AC power, even though the battery is off. I'll turn the battery on and you can see some of the stuff come back on that needs the battery. And the master caution light is on because we had a power disruption. Alright. So that's kind of the basics of our electrical system. This is, I'll go ahead and show you our door control. Our flight attendant controls our door. So when I push the attendant button down here, you'll see there's our door light, our master caution light. Up here you can see that opened the forward entry door and the aft entry door on this panel. Now when I close the doors, this time I'll just watch up here. When the door's shut, you'll see the overhead entry lights go out. I still have to add, there's a indicator up here that says overhead whenever something on the overhead illuminates the master caution light. I don't have that interface to the computer yet. I have to solder that connection. That's one thing I do want to connect that's not connected at this time. Yeah, I'll go ahead and show you the our stall tester function. That's up here on the stall warning panel, and it is illuminated now if I turn off that light. Okay, when I press the stall test, that tests our stall shaker in the yokes. That's an awesome feature. That really surprises people when that works. Show you another thing that happens when you lose all your AC electrical power. I'll turn these off again. AC power went out. Okay. It's hard to see, but we lost our main horizons. They dumped. Now we have to fly on our standby horizon here. Only the standby horizon is functional, and we also lost our autopilot functions, which is what happens in the actual aircraft. We can no longer engage autopilot. The autopilot's locked us. We're locked out. I can't physically move them up. But engage our generators. Now I'm not locked out. I can place these to on, which as you can see, actually kicked on. The autopilot is trying to fly the airplane even though we're on the ground. Don't move the throttles, that'll affect it. I'll disengage the autopilot. On our landing gear handle, anytime we're on the ground, if I move the handle out of the down position, our alarm goes off. To silence that alarm, I have to put the landing gear back into the down position. It's a nice safety feature. So shutting off the cockpit is, or shutting off the engines, of course, is really simple. Go ahead and do a couple things. I'll place our start switches to off, or ignition switches, I should say. And all I have to do is cut off our fuel to our respective engines. I don't have the APU on. I'm not connected to external power. So we'll see as our lights come off, our fuel cutoff light will come on one side. There it is. And then we'll lose power on that generator. Oh, and our generator light came on. There we lost all power. There we have no power on the generator indicator anymore. So all that's left is to place the battery switch to off, and we're back to a dead cockpit, ready for start. So you can see that we can do a fairly involved engine start process when you throw in setting up navigation, boarding the passengers, pushback, and talking to live air traffic controllers where you're actually flying to a destination. The engine start sequence definitely adds to the realism for that whole process. So that's kind of been my focus up here, is to give the sense of a realistic aircraft start in the 737. You know, one of my goals is to try to make this thing maintainable. So it's a combination of certain items are connected directly to the computer interface. Other items are lights just going through toggle switches. So things happen in a series of events. And so that makes the overhead system, should be, the way I have it set up, completely reliable. Now that it's going, it should just work. Basically should be maintenance free. So that's great for nice engine starts, engine shut off situations. It is limited on scenarios where you have aircraft system malfunctions, you know, hydraulics, fuel, that kind of thing. It's not really set up for much of that. It can do a couple things, but mainly the configuration is for a good engine start, engine shut off process, since this sim will, you know, mainly be used for flying a flight, for practicing navigation techniques, more than it will be used for learning emergency procedures. So, emergency system procedures. So that's that. You're looking at a lot of work right there to make that sequence happen. But I think the end result looks pretty nice.